So this question wants us to draw a Venn diagram. So we need to kind of remember that Venn diagrams tend to be 2 or 3 circles where something's called something, and basically this is the intersection. So the intersection is where the 2 circles overlap, and the union is where you take all the information from both circles, or 3 circles if it's the union of 3, and so forth. And basically they want us to recognise that this is the information to plot into these things. So they're saying that this is all the data, so this is all the set of data. So this is the universal set, so all the set of data. So in this diagram, then all the numbers 1 to 10 go in, where A are the multiples of 2, and they're telling us then other things that we can be thinking about. So they want us to draw a Venn diagram, so they're telling us to use A and B. This is telling us that the intersection is 2 and 6, so we're going to put 2 and 6 there. It's telling us that the union is 1, 2, 3, 4, 6, 8, 9 and 10. Well, 2 and 6 have already been used as the intersection. So A is the multiples of 2. So in this circle here, we're just putting multiples of 2. So what's left in here, which are multiples of 2, is 4, 8 and 10. So 4, 8 and 10. So that's 4, 8 and 10 used. And in here is the rest of the numbers that's left in here. So that's 1, 3 and 9. So 1, 3 and 9. And we then check, have we used all the numbers 1 to 10? 1, 2, 3, 4, right, 5's missing. 7's missing. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, okay, so we've checked all that out. So basically, that's what they want you to do for that particular question, is take some information, use the language that they've given you to create the actual Venn diagram. Okay. This question is saying, what is the probability of A dash? Well, we've got to remember that the A dash means not A. So basically it's not a multiple of 2. Okay, because they're saying that A is multiples of 2. So this is saying, what's the probability that we haven't got not a multiple of 2? Okay, so probability we know is a fraction. There were 10 numbers to choose from, not a multiple of 2. So when we go through, not multiples of 2 were 1, 3, 9, 7 and 5. So there's 5 of them. So 5 over 10, which is a half. Okay, so that's how that question could have been answered. Alright, so this next question talks about Johnny buys some boxes of pencils and packets for use at a conference. 40 pencils in a box, 15 pens in a packet. He gives 1 pencil and 1 pen to each person. He has no pencils and no pens left. So how many boxes of pencils and how many packets of pens did John buy? Okay. Alright, so it must be lowest common multiple, so we basically want to find a multiple of both 40 and 15. So if we write out some of the 15 times table, so 15, 30, 45, 60, 75, 90 and so on. Write out the 40 times table, so I've got 40, 80, 120. Okay, so this has not gone far enough yet, so 105, 120. Okay, so we can see that the lowest common multiple was 120. So in this case, this was for the pencils, this was for the pens. Oh no, that was pens, sorry. Pens were 15, pencils were 40. Okay, so pens were 15, so we had to buy 1, 2, 3, 4, 5, 6, 7, 8 boxes of pens, and we had to buy 1, 2, 3 boxes of pencils. Okay, so this was a kind of lowest common multiple question in disguise. Literally we had to think about no pencils, no pens left, so we need to work out what multiple of 15 is the same as a multiple of 120. Okay, so and it could have been any combination of those, so we could have had 6 and 16, because again you could carry this on, but the lowest common multiple would be a suitable answer. Okay, so we now have a missing angles question, and again we've got to give reasons for our answers, and we've got to work out the size of this angle here. Okay, so looking at the information we've got, we can see that we've got an isosceles triangle, which tells us that these two angles will be the same. So if we do 180 take away 50, we get 130 degrees, and then if we do 130 divided by 2, we get 65 degrees. Always add on the information you find to the picture, because it can help you see what you do next. It does say give reasons for your answers, so basically we're going to have to give the reason here as angles in a triangle add to 180 degrees, and here we're going to have to say base angles in an isosceles triangle are equal. So again, we're given reasons for all our choices, so that's the reasons why we did all those calculations there. We want to get to this one, so ideally we need this angle here. Well, we can see that if we do 180 take away 65 degrees, we end up with 115 degrees. 170, 180, yep. And again, we'd have to give reasons. Angles on a straight line add to 180 degrees. Okay, so that's given the reason for that one. Again, add it onto the picture, and then we can see that we've got a triangle. So now we can finish off with x is equal to 180 degrees minus 115 degrees minus 20 degrees. That's 135 degrees, so 45 degrees. And then we have to give the reason angles in a triangle add up to 180 degrees. Okay, so we finish on the answer line as x equals 45 degrees. Okay, so that was a missing angles question, giving reasons throughout and showing every calculation that we're doing. So, touchwood, full marks. This question goes on about finding out a value for x, and it's given us loads of information. It's about a parallelogram, so that is telling us that opposite angles are the same. So we can see that these two angles here would be the same. It's got x's all over the place. It's finding the value of x. It's shouting out at you, create an equation. So we've got several things that we could try. We could try adding it all up and making it equal to 360, because we know it's about angles. We could see that these two are going to be the same. That's probably going to be the easier. So 3x minus 15 must equal 2x plus 24. So there's our equation. Now we do the usual solving. So we need the x terms together. So take away 2x from both sides will give us x take away 15 equals 24. Add the 15 to both sides, tells us that x is worth 39 degrees. It says work out the value of x, and that's what we've done. So that would be that question done. If it said work out the size of an angle, then we'd have to put this value of x back into one of these and find out the value of the angle they wanted. So one of these picture questions with x's all over the place, doesn't have to be x's, could be y's, z's, whatever letter they want really, but as soon as you see letters involved and they want you to find out the value of the letter in some way or use it to get the answer for some other part of the question, then it's about creating an equation and then solve it in the usual way. Okay, so this question is talking about scales. That means it's accurate, so we can use rulers and compasses and things. It says a plane flies directly from A to B, so that's going to be a straight line, and it wants you to work out the time. How long does it take? So we can see that it's accurate, so we can measure that. 12.3 centimeters. Okay, so it said that every centimetre is 100 kilometres, so we have to do 12.3 times 100, which would give us 1,230 kilometres. The question mentions speed, so as soon as we see speed we should be thinking of the formula: speed equals the distance divided by the time. Now it's average speed, so technically you'd be thinking of total distance divided by total time, but it is only one journey, so distance over time is fine. Now it's a 3-letter formula, so we do have that triangle to help us think about what we're doing. And it wants you to work out the time that the plane takes, and it wants it in hours. Okay, so we're going to cover up time, and it's telling us to do the distance divided by the speed. So we're going to end up with doing distance divided by, so we need time is equal to distance over speed. So it's 1230 divided by 300. Okay, so 1200, let's switch it on. 1230 divided by 300, so 4.1 hours. So the question wanted the answer in hours, so 4.1 hours. If it wanted it in hours and minutes, then 0.1 of an hour is 6 minutes. So we could have said it's 4 hours and 6 minutes. 0.1 times 60 equals 6 minutes. So lots of ways of doing that particular question, but it was about measuring accurately because it told us a scale, and we then realised it was about speed, so we wrote down the formula. We wanted time, so cover time up, and it's distance divided by speed. Distance divided by speed gives us 4.1. Because this was kilometres and this was kilometres per hour, this must give us hours. So kilometres per hour, kilometres cancel, so we're left with hours. Okay. Okay, so this question has got lots of information in it, and it's talking about working out the total number of people who travelled by a car. So we had train and car, and we had 40 people, and we had male and female. Okay, so we could either do this through a frequency diagram, or a frequency tree should we call it, or we can do it through a two-way table. So let's do the two-way table over here, and then we'll show the frequency tree as well. Okay, so we had train, car, total, and we had male, female, and total. Okay, excuse me. So it tells us 40 people altogether. 13 of the people are male, so male is 13. 10 females travelled by train, and 8 males travelled by car. Okay, so that's all the information put into the diagram. So now we just fill in the missing bits. So if there's 13 males, so there must have been 27 females. If there's 27 females, then there must have been 17 went by car. The question said, work out the total number of people who travelled by car. Well, car was this one here, 25, so that's going to be the answer. So the answer would have been 25 by car. Okay, so if we're going to do it by frequency tree, then we had male, female, and then we had train, car, train, car. Okay, so it said 13 were male, so that allowed us to get the 27 for female because I had a total of 40. Okay, and then it said 10 females travelled by train, so that meant we had 17 by car, because 27, remember, it comes across, they must add up to 27, those must add up to 40. So we had a total of 40 to start with. And it said that 8 males travelled by car. And the question wanted the cars, so when we add those together, we get 25. Okay, so we could have done it by frequency tree, or we could have done it by two-way table. So either way, you can do it by logic and just work it through, but I think the tables or the tree helps you to see quicker how to get the answers when you've got questions involving lots of information. Okay, so that's an example of those. This question says solve the simultaneous equations. So we do the usual, we go through and think, what does that mean? It means we want the same number in front of, the same coefficient in front of one of the letters. So we can see here that we can either double the number of x's in the top equation, and that gives 4x there and 4x there, or we can treble the bottom one and we end up with 3y's in both. I'm going to treble because I know that the plus and minus is easy to cancel out because we just add them together. So that's probably going to be easier. So I'm going to times this one by 3. So that gives me 12x, take away 3y equals negative 3. We had 2x plus 3y equals 10. So once we've got the same number in front of one of the letters, we then either add or take away to cancel that out. In this case we can add because negative plus to positive makes 0. So we're going to add these to get 14x is going to be the same as, well, negative 3 plus 10 is 7. And then if we divide by 14, we find that x is worth a half. Okay, and then we put x equals a half into one of the equations. It doesn't really matter which one you do. It's got to work for both. That's what simultaneous is about. So 2 lots of a half plus 3y's must equal 10. Well, 2 lots of a half is 1. So 3y's must be worth 9 because we subtract 1 from both sides. So y must be worth 3. And we check in the other equation. So 4 lots of a half, take away the y number. 4 lots of a half is 2, take away 3 is negative 1, and that's what it was. So happy days. So we can see that the answer to this question was x is half and y is 3. Okay, so solving simultaneous equations then, you make the coefficient in front of one of the letters the same. And in doing that, we then can either add or take away to cancel that out. And then once we've got the value of one letter, put it into one of the equations to find the value of the other letter, and then check by using the equation we didn't use at this step. So that's solving simultaneous equations. Okay, so this question's given us lots of information in a grouped table. So we recognise this as groups because it's saying 36 students took between 0 and 10 minutes to travel to school. 18 students took between 20 and 30 minutes to travel to school, so it's grouped data. It says draw a frequency diagram for the data. Now you could do a histogram or you could do a frequency polygon. I think a frequency polygon is easier to do, so we'll do a frequency polygon. And that basically means you plot the middle of the interval against the frequency. And basically you'll end up with a series of plots, and because it's a polygon you must join them with straight lines, and that'll be frequency, and this will be whatever this is about, this is time. Okay, so between 0 and 10 is 5, so if we do the midpoints, so 15, 25 and 35, excuse me, so 5 to 36. Again, always think of scale. So here we can see that it's 1 square equals 1, so that's okay. And then the next one's 15 against 34. And then the next one is 25 against 18. And the last one's 35 against 12. Okay, so that's plotted the points. I think the key thing to remember is that in your real exams, the graph paper is much nicer to use. Photocopying and printing is never easy. It never seems to give the same quality. It's a frequency polygon we're drawing, so we join with straight lines. Okay, we don't join the front and back. Frequency polygons, just a continuous, like a time series. The school has 600 students. Estimate how many students take more than 20 minutes. Okay, so more than 20 minutes is going to be this group and this group. So 30 students took more than 20 minutes. Okay, so this is 100 students, so our estimate, estimated probability was 30 out of 100, which is 30%, greater than 20 mins. Okay, so basically from the table then we found there was 30 students that took more than 20 minutes, and that was out of the 100 sampled. So our estimate for this, it says estimate, we're going to calculate an estimated probability of choosing somebody who takes more than 20 minutes, and that's 30 out of 100, so 30% of the students will take more than 20 minutes is our estimate. So basically this question is saying, what is 30% of 600? So that's 0.3 times 600, which on your calculators you'll get 180. So that will be our estimate, that 180 students roughly take more than 20 minutes based on the sample. Okay, so that's a question involving frequency polygons and estimating from given data from a sample. Okay, so we've got a map and it's given us a scale, so that means we can use a ruler and compasses. Ruler, okay. It says work out the actual distance between Cagliari and Sassari. Okay, so because it's a scale question, it's drawn accurately, we can put our ruler, join the 2 points up. We can see on here it came to 7.3 centimetres. And because they say that 1 centimetre represents 25 kilometres, then we can do 7.3 times 25. Okay, so 7.3 times 25 equals 182.5 kilometres. Okay, so a map scale. Quite a straightforward question. Use your ruler accurately though, get your head over it, line a 0 up, and then measure as accurately as you can, and then work it out. The next part of the question goes on and talks about a favourite beach being on a bearing. Now, what we need to remember about bearings is they are always measured from north. You always turn clockwise, and you measure the angle they want. So 165 degrees is probably going to be down here somewhere. So we're looking at measuring that accurately. It's from Olbia, so basically we're stood at Olbia. Okay, so we get our protractor, line up 0, (165 degrees). So we know that the beach has got to be on that bearing. So that's 165 degrees. And because it's a beach, we know that it can't be over here somewhere because it's in the middle of the sea. So it says mark with a cross. Well, the beach has to be on the edge of the land, so it's going to be there. Okay, so that's a reminder about using bearings. Always line up 0 as north, and then measure in clockwise direction, and make sure there's 3 digits on the bearing. So scale and bearings. Okay, so we've got some data recorded here. It says calculate the mean. So the mean, we've got to remember, is the total divided by the number of numbers. So give your answer to the nearest whole number. Okay, so we need to do 21 plus 20 plus 29 plus 22 plus 24, 245. Okay. So 21 plus 20 plus 29 plus 22 plus 24 plus equals to get the total. So it's going to be 116 divided by 5. Show the examiner intermediate steps, just in case you make a silly error. So 23.2. And it says give your answer to the nearest whole number, so 23 runs. Okay. I think there's a mistake on the mark scheme here, because that wouldn't be worth 4 marks. So it's probably going to be worth 2. Okay, it says calculate the range. Well, range is high-low, so it's the highest value. Take away the lowest value. So the highest value in this case was 29, and his lowest value was 20, so 9 runs. So the spread of his runs was 9. It then goes on and talks about Tommy. Tommy recorded his results. His mean was 30. I scored more runs than Chris. Use the data comment in this statement. Okay, so 5 matches. So his total was 5 times 30, which is 150 runs. I scored more runs than Chris. Yes, Tommy did. He scored 150 runs. Excuse me. Tommy's range was 75. Chris says I was more consistent than Tommy. Yeah, the smaller the range, then the more consistent. So smaller range means more consistent. So Chris says I was more consistent, so Chris is correct. Chris is correct. His range was smaller, so he was more consistent. Okay, so that's a run through of calculating the mean and range, and then just making some comments based on the mean and the range. The smaller the range, the more consistent the data is, and so forth. Okay. So we have a recipe question here. We've got 20 buns, and it wants to work out what we need for 30 buns. Lots of ways of doing this. You could recognise that 20 and 30 are both multiples of 10, so we could halve this and add it on, and then that would make 30. We could do the ratio, 30 divided by 20, and then multiply all of those by the same ratio. Or we could make out what 1 bun is, and then times by 30. It's really up to you which method you prefer. I'm going to do 30 divided by 20 because I think as a calculator paper it's much easier. So 30 divided by 20 is 1.5. So we need 1.5 recipes needed. So we multiply everything by 1.5. Okay, so 180 times 1.5, 270. 150 times 1.5, 225, 200 times 1.5, 300, and 4 times 1.5 equals 6. Okay, so recipe questions, touchwood, should be fairly straightforward, guys. Just got to work out what pattern you like using. It's a calculator paper now, so usually dividing what you need by what the recipe does, and then that gives you a scale factor, and then multiply everything up by that scale factor. Okay, so this next question goes on and says rearrange. So that means swap things about until G is on its own, because we want G equals. So basically, when it says rearrange to make G the subject, then we want to get an answer where it says G equals. So we move things away by doing the opposite. So take away 2 from both sides because that's not involved with the term involving G. So do that first. So come top down. So we always do first thing take away. So F take away 2. That equals 3G. And then we're going to divide by 3. So G is equal to F take away 2 all divided by 3. So F take away 2 all divided by 3. Okay, so recognise rearranging and practice the skill because you need it for various questions, not just the rearrange question. Multiply out, so basically we've got to do x squared times 4, and then we've got to do x squared times x cubed. Okay, so timesing both terms inside the bracket by x squared, and you've got to remember that x has got power 1, so it's like doing x squared times x to the power of 1, and then when we're times over the same base of x, we add the powers, so that's why we get the cubed. Okay, so that's a range of questions to practice.